All right, so we're doing number one. This is these problems are from the homework of our law of sine and cosine word problems. So we're going to do number one, maybe two, and then see how we're doing with it. So we set this up where Jackie and Peter were starting their figure skating routine. Jackie and Peter, they start skating away from each other at 15 degrees. So 15 degrees away from each other. They're just moving away from each other, and that doesn't necessarily mean they're going in both opposite directions. 15 degrees is the angle between them. So Jackie goes 5 meters in this direction. Peter goes 7 meters in this direction. We're trying to figure out how far apart from them they are. And I knew we were going to use the law of cosine just because look what we have. We have an angle, and we have the side across from it that we're looking for. And then we have two other sides involved. So if I have that dynamic, I am going to use the law of cosines. Remember, we would use the law of sines if it was an angle and a side across from it, and an angle and the side across from it, we would use the law of sines. But when we're in this configuration, we're going to use the law of cosines. Mainly the thing to look for is we have an angle and a side involved, and then there's two other sides that are just not connected to an angle that we have information on. We don't know what the angle across from 5 is, nor 7. So we're going to use the law of cosines. And the angle and the side involved are always on the outsides of the values we're going to plug in here. So I'm going to put in x squared, and then a and b, it doesn't matter, 5 squared plus 7 squared, minus 2 times 5 times 7, times the cosine of 15 degrees. All right. So we have this situation now. And again, this is where it's just get your calculator out. Make sure it's in degree mode. 15 cosine. This right here is 0.9659. And I'm going to start to work out the rest of it. 25 plus 49 minus 70. You see, once you have it all set up, then it's just about calculator work. So let's work through it methodically. X squared is equal to, let's see, 74 minus what we just had in our calculator. We just keep it there and times 70, and it's going to be the negative version, negative 67.6. All right, and then 74 minus 67.6. X squared is 6.4. Square root that. Square root it to get rid of the square. X was squared, so we square rooted it. X is left over, and the square root of 6.4 is 2.53 meters. These were meters. So we know that Jackie and Peter, this distance right here is 2.53 meters. All right. I'll let you get caught up on that. And we'll look at the next one in a second. You know, and I wonder if I could just print this. Maybe I could just print it. Let's see if this works. Yeah, I think I can. Let's do it. So I don't want to switch back and risk the camera not working. So I'll just print this. We'll look at the next problem. But let me know in the chat. What would you say on a scale from 1 to 5? How do you feel about making the models and working these out? Yeah, thank you for one person. Good. 2 people. Yeah. All right. All right, we got 3s and 4s. It's actually mostly 4s. We got a 3 in there. So we'll do another one. We'll see how we feel about it. Okay. So we just did number 1. I just printed it for us. So now let's look at number 2. And I'm going to work on number 2 outside of your view over here. And I want you to work on it. And let's see if we get the same. Let's see if we get the same model. Okay. So I'm going to work on mine over here. You work on it over there. A bridge is supported by triangle braces. A bridge is supported by triangle braces. If the side of each brace have a length of 63 feet, 46 and 40 feet, find the measure of the angle opposite the 46-foot side. This isn't really that. This is just making a triangle, but let's see about the braces here. You know what? I'm not sure if everybody knows kind of like what these braces would mean. So I'm gonna help out with this one. So we got this bridge, right? And a brace is kind of like a brace is like here's the wall, here's our brace. So maybe that helps you. Go ahead and from there, these are braces. And let's go ahead and create our triangle from that. So if the side of each brace have the length 63, 46, and 40, find the measure of the angle opposite of 46, the 46-foot side. I'll give you just another minute to get that triangle set up. This isn't necessarily a right angle. We don't know anything about the angles. Let's go ahead and make this 46, 40. All right, your triangle may look like this. It may look different, but that's what I drew. Okay. I could think of other ways that you could have drawn this. It wouldn't make any difference if you made the triangle like this. If you were thinking that it was like, here are the braces for your bridge, right? You could have made it, get that out of there. You could have made it like this, right? 63, 46, 40, theta. So, based on how you represent this triangle, you could have it look a little different. But if you have it so that you generally have, you're looking for theta across from 46. I mean, there's three sides of a triangle, so it's lucky. It's like once you have two of them in there, you have one more left, and you know where it goes. All right, look what we have: angle and a side, and then two sides. So which one are we going to use? Tell me in the chat, C or S? C or S? Sine or cosine? Law of sine or cosine? Give me a C or give me an S. What do you think? Yep, it's our favorite. Yeah, exactly, Alicia. I know. I like the law of sine as well, but we have to do it. Okay, and we're going to find the measure of the angle. We're going to do it in degrees because they didn't specify. So remember that the angle and the side across from it always go on the outsides. That is the key. If you can remember that and you have the rest written out, you can just access the other sides and throw them in the middle. So 46 squared, 40 squared plus 63 squared minus 2, 40, 63 times the cosine of c degrees. Those are all values that we can work out. Yeah, cosine, law of cosine there's a lot to it. 2116. Oh, that's 1600. 3969. Minus 5040 cosine of c degrees. This is just isolating so that this over here is by itself. So I'm just going to start, subtracting this over. So just kind of get it by itself here. So 2116 minus 5569. So we get negative 3453, and that's all equal to negative 5040 cosine c degrees. I know that this is like painful process, but I know everyone could do it. I know it. You can do it. It's just a matter of, okay, I need this. It's times the negative 5040, so I need to divide by the negative 5040, both sides. So we end up with 0.6851 cosine of c degrees. Believe it or not, we are finishing this up. Instead of the cosine, I can't take the cosine of an angle I don't know. I need to find the angle. So I need to do that inverse cosine, cosine negative 1 on both sides. That cancels the cosine on the right side. So what I end up with is the measure of angle C I'm going to get when I work this part out. (46.8 degrees). Nice. All right, this is the level of all of the problems here. So maybe give me now just a thumbs up, sideways, down on how this set of problems looks. Yeah, better. How about on a scale from 1 to 5? Let's do that instead. I can't see everybody, but everyone usually gives me the numbers. So give me a 1 through 5. What do you think? 1 through 5. Yeah, 4s and 5s. Yeah, 4.5. Yeah, I'm giving you numbers 3 through 7. So I'm giving you the rest of it. So if you're still struggling with it, don't worry about it. We are going to be able to look at this on Monday, and everything we're doing moving forward is very similar. I'm going to go and stop the video.